Good morning, everybody. So, I want to review what we talked about last week with forces and motion. I'm going to review some of that vocabulary and give some more examples before we go into the laws of motion starting tomorrow. So, let's start with what forces are. So, it's a push or pull on an object. Now, this can cause the object to then go into motion. It also can cause a change in shape. And there is a formula for force. All right. When you multiply the mass of an object by the acceleration, you get the force on that object. Okay. So mass is the amount of stuff, the amount of matter in an object. And then acceleration, as I'm going to review again today, is that change in speed. How fast, how much faster or how much slower an object is moving. And then you have a numerical value for force when you calculate that, and it's measured in newtons. All right, newtons is the measurement, is the unit, and that's because Isaac Newton was really instrumental to this form of physics. So we have balanced forces. Balanced forces are when the forces are acting in opposite directions and are equal in size. Here we have balanced forces because there's 12 newtons, right? Newtons is what forces are measured in. This would be a force diagram. And these are in opposite directions and they're equal. Same with this up and down. You would probably assume that this downward force is gravitational force, gravity pulling it towards imagining the ground there. And this would be the normal force, a force that the ground then pushes back up on the box. So when you have a balanced force, since there's no extra force in any direction, if it was staying still already, it will remain where it is. But if it was moving, it's going to continue to move just at the same speed and in the same direction. Only when you have an unbalanced force will you get a change in speed or a change in direction. So, unbalanced forces cause a change in the motion of an object. This can either be in its acceleration, which is a change in speed, well, change in velocity, so direction or amount of speed. Now, net force is the combination of all the forces on an object. So we see here that this box in the force diagram has a 10 Newton force to the right and a 14 Newton force to the left. So since they are in opposite directions, we would subtract these from each other, and the net force would be 4 newtons. If they were in the same direction, both going to the right or both going to the left, you would add the forces. Net force, just like applied forces, are measured in newtons. Friction is a force that is caused when two objects are rubbing against each other, and it causes it to slow down. So if you've ever ran and then slid on your socks, the reason why you don't slide forever is because of that friction force. Friction is slowing you down because it's a force that's acting in the opposite direction. It's also how brakes in a car work. So it is when you're rubbing two objects against each other. Same thing happens with your hands. As you rub your hands together, friction is actually what's causing the heat. Now let's go into those motion vocabulary words. Speed. Speed is a way of measuring how quickly something is moving. Now, speed can be 55 miles per hour or sweeping the floor for 5 minutes. It's telling you how fast you're doing something. Now, there's a key difference between speed and velocity. Velocity is now speed with a specific direction. You would be saying 35 miles per hour west, giving that direction. So, reviewing, speed and velocity are very similar, but when you talk about how fast something is moving with direction, it is now velocity. Then there is acceleration. Acceleration is different than velocity. Acceleration is actually the change in velocity, the rate at which an object changes its speed or direction. Since speed and direction is velocity, any change to velocity is acceleration. This can be going downhill on a roller coaster since you're speeding up. This could be going uphill on a roller coaster since you're slowing down. Or this could be turning the corner in the roller coaster because you're changing the direction. A change in speed or a change in direction would be a change in velocity. And a change in velocity is what acceleration is. So applied forces are when a force is applied to an object by a person or object. This would be you literally pushing it or pulling it. This is different than a gravitational force, which is not an applied force, because gravitational force is not like a contact force. So looking here, trying to match these up. 65 miles per hour north versus 10 miles per hour. They're both saying miles per hour, but one has a direction. That direction tells me that 65 miles per hour north goes with velocity, while 10 miles per hour would go with speed. Direction being the key difference between speed and velocity. Then, when I read rubbing hands together to warm them, that is friction. Friction releases heat as two objects are being in resistance to one another. So C would go with friction, number one. Turning a corner, but not speeding up. So speed is the same, but direction changed. Either way, if it's a change in direction or speed, that would be acceleration. So D would be for acceleration. And then for applied force, pushing a bike up a hill. You are applying a force to that bike. So applied force would go with pushing a bike up a hill. What I want you to do now is answer the 5 questions that I have in the Google Doc, reviewing this material so that you are ready to move on tomorrow. Thank you.